Alright, I thought we would have another go at this power supply. In the last episode I actually put on a switch on the front panel. I put a power switch at the back. I can switch it off there. Takes a while for the capacitor to discharge. And I put a switch on the front here which actually does nothing more than disconnects the two power supply boards from the relay switchboard, which worked okay as far as when it was set to independent mode, but when it was set to serial mode or parallel mode, it doesn't show any voltage when it is disconnected from the output. And only when you switch it on does it actually show the actual voltage that it is set to. Now it does the voltage control which one is it? Oh, it is the voltage control does work. You can kind of set it, you know, to a different voltage. There you go, 50.6. And as soon as it goes out of setup mode, of course it goes back to 0. When you turn it on, it will be at the voltage. So it kind of works. And I could kind of live with that, really. Of course I don't use it in serial parallel mode that much. However, I have also noted that since I put in the, if you look at the other episode, I put a little relay board at the top to actually switch these off, and it's got extra wiring. It goes up and it goes down to the board and then so on, and perhaps those wires are working as antennas, I don't know, but I'm getting like hundreds of millivolts of noise now, 400 or 500 millivolts at least, and which is too much. So I've decided to have another look at this thing, and we're now going to put some filtering in to avoid that, but maybe relocate some of those boards and probably make up a PCB with some extra relays on it, and we are going to be switching those three outputs here rather than switching it directly from the two boards that are inside of the machine. And we're going to add some extra filtering as the outputs of the two power supply boards to see if we can make it fairly noise free. So that's what we're going to be doing. Okay, so after quite a bit of experimenting over here, I actually got these cores on AliExpress. I have no idea what kind of ferrite this is, but they're supposed to be used for chokes. And as you can see, I've tried several different windings on these things, and I got a little board over here that I made earlier, which actually puts a choke on both on the negative and the positive, but right now I am testing, and this seems to be the way to go. It's a little bit hard to see over here, but I made up a little board that I can actually hook up these different chokes with, and a few capacitors and stuff. And this seems to be, now this is obviously a terrible hookup, because I got twin flex, 14 gauge twin flex. It has to be 14 gauge because, you know, you got to be able to draw 10 amps per module over there, so you got to have hefty wire. I got 1, 2, 3, 4, 5 windings on this core of this, and what we're actually doing is we are creating a sort of a common mode filter like this. That seems to work the best, and I have a whole bunch of capacitors here. I have an ESR meter that I've used to find out which ones of my capacitors have the lowest ESR. These solid aluminium ones seem to be the best. Maybe if I change cameras you can see it a little bit better. These solid aluminium ones seem to be the best, but I've got 220 microfarads at 35 volts, and I've got 100 microfarads at 50 volts. Now the maximum voltage is going to be 31 volts, but I decide I'm going to use the 100 microfarads at 50 volts. Gives me more of a better spread there. And I found some little disc capacitors over here that seem to have good frequency response, and I also found some older capacitors that I had laying around. This one here, these 100 volt ones at 100 microfarads. They seem to be doing a good job as well, so I might, as you can see, I've doubled them up over here. I've got both of them over there. So in any case, I didn't cut the wire off on this. I didn't want to cut the wire yet on this thing, so I've got a wire with a choke on it, but a very big long lead going to the other side. So but nevertheless, what we have is this, with that filtering capacity. Now I've measured the inductance on that choke here is 236 microhenries, which is not a bad value. So even with 5 windings on there, this core seems to be doing a good job. So this is kind of it's not drawing any current right now, but this is what it looks like with no current draw at 12 volts. Drawing is about 3 amps. Turning it on here, it gets a bit jittery, but it's actually not different. As you can see, those 20, 19, 20, 24 millivolts. Now if I take this choke out and connect the oscilloscope directly to the output of this thing, this is what you get. This is with it turned on, and this is with it turned off. So in any case, this is what we have to solve, and as you can see, that filter was actually doing the job. Wherever the noise is coming from, it is filtering it out quite well, and this is what we're going to have to do. So the plan right now is, so what I am planning to do right now is putting one of those chokes on these two outputs here of these channel 1 and channel 2, with some little capacitors and what have you, filters between those. So therefore the input will be filtered through the existing relay board, and then right now I have relays to cut those two inputs off, but I'm going to be cutting off those inputs over here. Is the plan, with 3 relays instead of just 2 on a separate little board, and I will also put some extra capacitors, some filtering and so on that as well, and see how we go with that. Okay, so here we are. I have pulled the power supply apart, and there are some interesting things here what I've spoken about before. Over here there is 4 little connections where these boards are mounted on. Now normally this board here with the relays on it is mounted at the bottom. This one goes above it. And if you've watched the last video, I made up a little plate with the relay board on it that went on the top. And in order to do that, what I was actually doing was these are the outputs to the two power supplies, channel 1 and channel 2, and I got the idea of switching these guys off with some relays, and this is the relays that were on the board. I've taken them off already. But what was happening was that these things that were then connecting to the board at the top, and the board at the top then outputs to the actual relay board through these wires. And of course, as you can see now, the wires are fairly long. Before, there were just one set of wires which were even a little shorter than these, and they went straight to the relay board. And what has been happening is that because of the extra length of the wires, probably it was picking up a heck of a lot more noise. Before I made the modification, I was measuring like 75 millivolts ripple, but after I did that, I was seeing 150, even over 200 millivolts at different times ripple, and that is just not very good. And also because what we actually want to do now is to take the output of this board here and these three red ones and actually switch those with a relay instead of the input. Now, one of the reasons we want to do that is, if you look carefully, and I should have seen this before, but I wasn't taking any notice, there is current sensors over here and voltage sensors on this relay board. And when you got it in independent mode, you will see that there are current sensors on the actual individual boards, and they have a socket on there, and here's the cable for the bottom one, which talks to the controller board over here via these sockets, and it then is able to display the voltage that it is set to, even if the voltage to from these wires is interrupted via the relays. But when you get to serial and parallel mode, you see, to remind you, these are the independent channel 1, channel 2, but when you set it to serial or parallel mode, now you take your outputs from these sockets here, and they go to this relay board, and this relay board in turn talks to the controller board, and well, it ends up that when you switch off the voltage from these two wires to the input to this guy, then of course it can't measure the voltage. And what we are going to do also is, I've got some really heavy duty cables here with some chokes in the middle, and we're going to try, these are wired as common mode noise chokes, and we are going to try, and we're also going to add some extra capacitors to the outputs and the inputs for filtering, and we're going to try to connect this cable here with the chokes, and this cable then will connect, I haven't cut it to length that it's way too long right now, to a new board that, no, not to a new board, it's going to be connecting to this board rather, and then there's going to be a new board which I'm planning to put right at the bottom here, and I have already laid it out, and it's kind of, this is kind of what I printed out that the outline the board is. It's going to be placed on the bottom here, and actually it would be like this, and these pads over here are going to be lining up. These wires are going to be removed, those three red ones, and I'm going to take some solid wire over here, which is going to be connecting this board to the board underneath it, and the board underneath it is going to have these relays on it, and they are going to then switching the three outputs over here, so therefore it can still measure the voltage on this board and display it correctly when it's in serial and parallel mode. That's the theory anyway. So what I have done is I have went into Kicad, and I have laid out sort of a very simple circuit over here. It's got an output for the LED for the switch, so it shows when it's on. The LED will be on, and this is like the outputs from the switch. If it's on, there will be 5 volts on there. These are 5-volt relays, and just connects on, on. So all 3 of them will come on at the same time, and I'll hit the switch, and then this will become the outputs to the little banana sockets on the front panel. And so there's not much to those. There's some mounting holes, and the board actually looks like this. It has to be double-sided because I can't get access underneath the relays, of course. They have to be, they're actually soldered. The blue is the bottom side, they'll be soldered to that. And there's only one here that has a connection to the top as well. I'll have to put some foil in there to make that hole, because I'm going to make my own PCB to start with, to make that like a similar to a true hole, plated hole. And similar with these guys over here. I'll have to make sure that they can be soldered from underneath, but that it will connect to the traces on the top. But rather than just have traces, I have also put on the top some, let's get the, this is the background turned off. So at the top you can see I have just flooded the area here with areas. So these actual traces that you see over here are actually completely sort of unnecessary, because they are going to be, all this red area is going to be copper. And similar at the bottom. At the bottom I did the same thing. You can turn off the zone. See, there were traces there, but I just, right over top of them I put zones, because this is high current. One of those relays over here will be, I think it's this one, the serial parallel one, yes, they will be outputting up to 20 amps, so that is quite a bit of current. And I will even solder some wires to these terminal connections here, because I've got some very old PCB, double-sided PCB. Is 45 years old. I bought it. It's been to 4 different countries and many different places where I worked during my career, and I never actually used it, so I've now finally got to use a piece of it. And I don't know how thick the copper on it is, and working out the current capabilities and stuff. I mean, why bother? I will just solder some of that wire across from there to there, and so on. It seems to have 2 common connections over here. See, they're connected together. I don't know why, but on the original board they were connected together as well. So I am therefore connecting those together. And there is 2 little outputs for the switch and the LEDs. And these guys here, they are the first, those 3 here, they are supposed to line up with the outputs of those 3 red wires on that board, and the other board goes right on the top of it, and I can post some solid wire right from here to the board below it and connect them together that way, so there is no wire there to pick up any noise. And the actual capacitors that I'm going to be using, I will just solder to those pads underneath as well, with the little legs and so on. I didn't put extra pads in there for them. That's fine. So that's what we have. Okay, so I've made up the PCB, and it is double-sided, and because of that we don't of course have plated true holes. So what I have already done is I've dry fitted it in the machine to make sure everything fits. But what I have done so far is I've soldered in a few little wires here. As you will see, they go to the other side because we don't have plated true holes, and they are actually going to be soldered from this side. You see, the relays are going to be fitting on here. Let's do this one here, like that. And As you can see, the little legs on the relay just poking through there, and I'll be soldering them with these wires, so that means that they will be making a contact with the traces above, which is what we need for that one. Now the other holes here, none of those are needed to be plated through, because as you can see there is no connection around the pads except for this one and that one. Those two over here expect to be plated through. So how are we going to do that? Since those are potentially high current holes, I don't want to put just a thin piece of wire in there, so I got the idea of using this copper foil over here. I've got a roll of it. You see, it's like sticky copper foil. It's got like sticky tape on one side of it. I have wrapped a little bit of it around this prying tool, and the idea now is I'm going to try, I don't know if that's going to work, but it's an idea, is to put it through the hole like so, and then remove the tool, or rather what I'll do is I'll splay it out on the other side. Let me get yet another tool here. Okay, so I've got a little tube of copper in there right now. I guess it's hard to see because it's not focused very well, but and if I put this in the middle like that, I should be able to find a tool in order to display that out. Maybe even one of these guys, but anyway, let me see if I can display it out with this little tool first. Maybe a little snip. Okay, so I've got a little tube rolled around here. Yeah, this is going to work a lot better than the other one. And take a little tool here and first of all splay it out a little bit. Little screwdriver there to flatten it out. Okay, solder that on. As I said, don't have to solder this on too good just to hold it in there. And now on the other side, this is the side that's going to be covered up by the relay. Okay, that will work as plated through holes. Now, let me go and mount these relays on there. This is number one. Okay, now, so what's going to have to happen is this old relay board here is going to be mounted on top of this one, and in order to do that, we're going to have, where are they? These, no, not these, those. You're going to be using those standoffs. That's going to be mounted on there, like so. And these holes over here, 3 of those are going to be matching up. I'm going to remove those 3 red wires here, number 2, number 4, and number 6. And the idea is that these two are going to be mounted together, and I'm going to be using some of this thick copper wire to go through from the top to the bottom over here to these holes, like that. So that's going to be a bit fiddly, and I'll probably do that off camera. Okay, so what I've done so far is I have soldered up the little PCB I made up. It's got the 3 relays on there, channel 1, channel 2, and serial parallel, and these are the original relays. These guys are running at 12 volts and the new ones are running at 5 volts on account that I've got a spare 5 volt socket on that power supply underneath here, so that's 5 volt out at 2 amps. It's currently drawing half an amp or a bit over half an amp for the 3 relays, but that should be capable. It can draw 2 amps without any problems. Now what I'm actually doing right now is I'm checking these relays actually have to run at fairly high current, and I am, because the PCB I made up, I don't know how thick the copper is, so I'm soldering on some extra little wires over here. I'm going to do this one over here, but we're going to measure the actual how many milliohms the resistance is, because don't forget, channel 1, channel 2, they will both handle 10 amps each, and this one here can go up to 20 amps, so it's very important that it is very low resistance, otherwise it's going to drop a considerable amount of voltage on them, and then the voltage on the display, and that's going to happen anyway, but the voltage on the display might say 12 volts, but you might only get 11 volts, it's kind of like, so that's what we're up to. Now what I've done is I have hooked up these thick 14 gauge cable that I had laying around. I've basically made a common mode chokes out of these. I've actually got some capacitors here connected to these connectors, and what I've actually done is I put in the power supply, used these XT60 connectors, which are actually made for lithium ion cells, and they can handle more than the 10 amps that they require. So and that's goes to the input, and the output actually goes directly to these nano sockets here. So in any case, but what I'm doing right now is I've actually soldered on a wire over here, but I haven't connected it yet, because as you can see, for channel 2 the current has to run through this trace over here, goes into this pin on the relay, and then comes out on those 2 pins, and then it goes to the output on over here on channel 2. So, but I'm curious how much resistance we have there. But before I do that, all the wires I put sockets on so I can unplug them. Before they were all soldered in hard, so you'd have to unsolder them if you wanted to get connections, and this makes it much easier for me to test and so on. Here's a little one that connects with that one. That's for the LED that's inside of the switch here. This is the 5 volts that's going to come from the channel 2 5 volt output, and that's of course going to connect to here, but for now I've got it a little plugged in, and I'm going to hook that up to my bench power supply to test it. But before I do that, I'm going to put some hot glue around where these wires are soldered, because when you're fiddling with them and wiggling them back and forth and so on, they tend to break. So this will actually help to stop that from happening while I'm experimenting here. Alright, that should do it. I can unplug that. Alright, so let me get rid of some stuff here because it keeps falling on the ground. Alright, so let me see now. Here's our milliohm meter. Some of the glue got on there. Here are the leads. Now, milliohm meters tend to have 4-wire inputs. How that actually kind of works is it's a little bit more complex than that, but to give a simple example, there is 2 wires going to each plug, and the machine simply measures the resistance of the one wire, basically, in principle, and so it knows how much voltage is being dropped on the wire, and then it can actually measure the voltage on the other wire, and it says, okay, now I can adjust it because I know how much resistance is in the wire, so it nullifies the actual resistance. However, before we do that, we make sure that it is zeroed. There we go. Very sensitive. And now we're going to hook up this channel 2, and then we have that's channel 2 input, and the channel 2 output, of course, is here. And of course we have to then turn on the relay. It will do here, and like that. Now I'll turn on the voltage on my bench power supply. Let me double check. Yeah. Okay, well, we've got more than 20 milliohms after all. Now we got 25.8 milliohm. Now let me check if this one is actually zeroed on that scale. It isn't, so I have to make an adjustment here. Okay, now we are going to connect this, connect that, and we got pretty much 25 milliohms. Now okay, 25 milliohms, 0.25. Enter. According to Ohm's law, voltage is current times resistance. 10 amps. So that's going to be 0.25 volts, quarter of a volt. I guess that's not too bad, but that means that if we got the because this thing is actually measuring the voltage and current right here on this board, and the power is coming through this cable going through the relays, potentially 2 banks of relays now, and then it goes to the output. So there's wire there, and because I put this choke in here, there's more wire here than there was before. We actually will end up with 11.75 volts on the actual output instead of 12 when this says 12. But let's have a look now. I'm going to turn that off, and I'm going to turn that off, and let's have a look now. If I solder a piece of wire from here to there, that will lower the resistance. I think that is long enough if I make it that long. We're just experimenting here, you know, we're just hackers really. And after I've done this, I'm going to make a PCB up with some extra holes for wires and things, and the capacitors which currently are sort of on the wires, I can put those on the board as well, and I'm going to actually have it made by one of those PCB makers. So one of them, Next PCB, I think they are called. They have actually asked me if they want, if I make a video and highlight their procedure how to do it. So I might do that. Okay, so soldering iron. I think a little bit of flux makes it easier. And some solder, where did I put it there? To buy some more solder soon, I'm gonna run out. Okay. It's gonna get hot, so I'm gonna use tweezers. Put that there. And for good measure, we can even put some wire here, yes. I don't know if this is going to make a great deal of difference, but what the hell, why put a chunk of wire between these two here. These are actually supposed to be the same, actually a common output. And see if I can tack that on this side. No, let's put on extra solder first. I mean, we're not going to end up with 0 ohms there. There's always going to be some resistance, but we're just trying to limit any extra resistance that we may have caused by putting another relay in between. Okay, so let's measure the actual resistance now. This one is hooked up, that one's hooked up. Okay, so now we have 13.5 milliohms, and that of course is going to be 12.9. It's actually still counting down. I guess the temperature of the solder joints has, when it's hot, there's more resistance. Yeah, the wire that I put on is hot, so let's say it's 12 milliohms. So that's 0.12 volts, which is still counting down. So that's acceptable, I think. So now what I'm going to do is I'm going to put, I've already put a piece of wire there, but I'm going to put some extra wire and stuff on on channel 1 as well, and then we will put it together. Kind of looking, is that a good solder joint there? Yes, it is. It just got a shadow on it. All right. Okay, so I have the electronic load connected right now. It is set for 3 amps, no matter what voltage it will be. Got it connected to channel 1, which is 12 volts. And of course the voltage is 0. Let's turn it on. And there you go, 3.001 amps. And we have 11.884 volts, which is kind of what we were expecting. The the wires over here, they have resistance and so on, so they will drop the voltage a little bit. And also there was some internal resistance. What did we measure, like 20 milliohms or something? But in any case, that is good. That's what we're expecting. And if we transfer this to channel 2, we get 3.24 volts, 35 volts, and again we got 3 amps. And let's switch that off. There we go, no more voltage. That's what we wanted to achieve with that switch here. Power switch is now at the back, and I'm going to switch the okay, the electronic load is off. Now we're going to look at the parallel and serial and parallel mode. Serial, you're going to get 50.6 volts at 3 amps. That's going to be 150 watts. It's going to be interesting. Oh, I haven't got the power turned on yet. There we go. All right, 2.94551 amps. So that's kind of working as well. And switch it off. And now we're going to parallel mode. I kind of fiddled with those voltages before. That's what I set them to, just for nothing specific about those. Okay, 11.61 volts. Turn the power output on, 2.949 volts, and everything so far so good. 11.5. You would expect that, because when you're in parallel mode, now both of the power supplies, channel 1, channel 2, are in parallel, so therefore you're also having the internal resistance and everything as well, so you would get a little bit closer to the voltage that you set. It's only, you know, some millivolts lower and so on. Now let's have a look at if we have fixed the noise problem, and we're having less than 20 millivolts now. That's external noise. Anyway, I am very pleased with how this turned out, and I now can use this as a secondary power supply. As I said, I'll have another one which is a higher quality, you know, one already, but I do not feel that I need a linear power supply and spend $600 or $700 on that. And this, now with the modifications I made, I am quite happy with this now. Turn it off, the output, and switch in the back. I can turn the power off. Always channel 2, always the last one to turn off. And that's it. Turn that off. Alright, so I think that this was a project that turned out pretty good. Okay, so this is what we ended up doing. We put filters in between the two channel outputs, and this is the filter that I'm using. It seems to be successful. I've got a 100 microfarad capacitor, and this is a solid aluminium capacitor I use because they are ultra low ESR. And I've got a little ceramic 0.1 microfarad capacitor there for good measure. I have the green ferrite cores, which seem to work perfectly, but I'm using very thick wire here, 14 gauge and twin flex, and I could only get 7 turns on there, but of course there is 2 pieces of wire in there, so the total would be 14 turns if you like. And on the output I put 150 microfarad electrolytic, also a low ESR one, and another 0.1 microfarad capacitor, and that seems to filter the output from the 2 channels. There seems to be no real EMF or noise coming through that way, and those filters are then feeding the existing relay board, which actually switches, from independent mode. It goes straight through to channel 1 and channel 2. If it's in serial parallel mode, it either puts those 2 in series or in parallel and outputs it on this series parallel output. On those outputs, so that existing relay board, I put new relay switches, and so therefore the little front panel switch, I can actually switch the outputs off, and that way the current sensing is done for the serial parallels done on this board here, and the current voltage sensing for the channel 1 and channel 2 is done on those boards there. So that's one of the reasons I wanted to use a really thick wire, because I don't want to have much of a voltage drop. And I think as you saw, we are down to 20 milliohms or less for the entire output conductors and so on. And these outputs then goes into the banana sockets, and that is what we've got, and that's what seems to be working well. The relays, of course, are being driven by the 5-volt output that is available on the channel 2. There's an empty socket that it wasn't used. The socket on the channel 1 is used for the little USB front panel 5-volt output. So I'm using the secondary 5-volt output that no one was using to drive 5-volt relays here. These relays here are being driven by this board, and they actually are 12 volts. I didn't want to add any more load on that because I don't know what the current capabilities of that 12-volt output was. But I know I had up to 2 amps available at 5 volts, and the new relays, they're drawing about a half an amp between the 3 of them, so that seems to be okay. So that's what we have, and it works well. Well, that's it then. I think that was a successful project as far as I'm concerned. Saved some money. The upgrade didn't cost that much, just a few dollars for some little relays, and the power supply cost me less than $100, so that was kind of well worth it. So don't forget to subscribe and like and all that kind of stuff, and I'll see you guys in the next video.